Hello guys, welcome to my channel. I am back with another short video. This I had promised in one of my earlier videos related to when I was explaining about the Spark Web UI, that I will explain why scheduler delay happens and how we can see. So in Spark UI, when we see under the DAG visualization, we have option of selecting show additional metrics. If there we add this checkbox which is called cellular delay, then it will start to show like how much delay was there in the scheduler to schedule that particular task. So this is how we can see in the UI. But let's see what how tasks are executed in Spark. So what happens is a compute task is in the driver decide, okay, this is one compute task, so it prepare that task as a closure, so it will do a serialization of that particular task. Then it will request the RN resource manager, which is, let's say, can be Yarn or it can be Kubernetes. It will request that, okay, boss, I need an place where I can run this task. So it will resource manager will go ahead, it will create an executor. So once it create the executor and will inform driver that, okay, here is one executor where you can run your task. So after serializing that task, it will send that task to that particular executor. Executor will deserialize this task, and then it will execute the task and then serialize the result and send back the response back to the driver. So this is whole flow of how a task is nothing but a unit of work gets executed or gets distributed in Spark. So now this is the summary that this is what I talked about, and this is where things got. If you see the timeline wise, so stage is submitted, and then there is this gap. Then where this driver launches this particular executor or task, then there will be some gap. Then deserialize time, run time, and serialize time, and then again there is some gap. Then fetch start time, and then getting the result and finish time. So this is the whole flow, like timeline wise. These things happen on executor. So this gap that you see is a scheduler delay, because executor did its job from this to this, but the driver was running from this to this. So there is a gap, like this one is a scheduler delay, and this again is a scheduler delay. And to understand how much scheduler delay happened is the total duration minus the runtime, which is this one, minus deserialized time, which is this one. The- that is the task to deserialize the task that has come from driver. Then serialized time, this is nothing but the serialization of the result. And then is the getting the result time, which is this one. So these things which are in highlighted, so everything else which is there is a scheduler delay, or everything else that is remaining contributes towards scheduler delay. So there are many reasons why we should see a scheduler delay. One is that there is a resource crunch in the cluster. So if a resource there is a resource is not available, or the executors are occupied by other tasks, then the current task may be queued up and resulting in scheduling delay. Let's say if there is a slowness in launching the task, which involves getting a thread, possibly a new one from a thread pool for a Spark task to run, again it might do a delay. If there is a data skew, then what will happen is that calculating tasks for some partitions may take maybe more time consuming than for others, and hence there will be a scheduler delay. It may be because of network delay, network latency. If network latency between different nodes is high, then the task may have to wait longer to access the required data on the computing resource. That's again will be a scheduler delay. If we are doing locality aware scheduling, let's say we want to say that only launch executors where we have the data locally present. So in that case, if there is no node available which has that particular data, or some other executors is running on that, so it has to wait for that other executor to get removed so that the space is there and it can launch. So locality aware scheduling can cause a scheduler delay. Then we have slowness in sending a task or a message from the scheduler to an executor to launch a task, that might also create a scheduler delay. Similarly, while receiving the task, there also can be a delay, so that adds to the scheduler delay. If scheduler launches too many tasks in short period, in that case what happens is there is an overhead on the driver to manage all those tasks metadata, and that may cause further delay in tasks to be getting either getting queued up or not getting processed immediately. And if the node hosting the driver is under heavy load, it might slow down the sending of the task to executors. Like let's say there is a network capacity for each node fixed, and let's say something else is running and consuming that network bandwidth, then the driver will not be able to send that task, and hence there will be a cellular delay. So there are many reasons why there is a cellular delay. Generally, this cellular delay does not impact the total job per se, but if you are running streaming workloads, then you should be worried about this if you see cellular delay. But in batch cases, generally the total runtime of the job will be way higher than this small cellular delay thing. But this is good to know. And things to fix this is to to increase the driver memory and the cores, launching fewer tasks, launching smaller tasks with smaller results, or having cluster enough resources by adding more nodes, or solve the data skew problem which is there, or reduce the task waiting time by optimizing the network configuration, like using let's say an uh, tuning your workloads. Let's say if you are running on AWS, moving your driver from let's say C5 to more network optimized from C5 you can try out let's say I series, which has more network bandwidth and instant storage also there. So that can be one approach. And one two notes are there. If thing is, if you are seeing SDFS commit issues, this is not linked to scheduler delay, and long scheduler delay on Spark UI, but might have failed because of GC overhead limit exceeded due to other reasons. Fix those before working on scheduler delay. So this is something that's what I mentioned is generally scheduler delay is something which should not be your primary concern. You should fix other stuff first. But yes, this is good to know that how Spark runs something and why there is a scheduler delay if it is there at all. So yeah, that's it. Have a nice day.